Hi everyone, in this video we'll take some examples about how using the squeezing theorem. Now in part A we have limit x to the fourth sine 3 over x, and you have to use the squeeze theorem. You know that sine any function is between -1 and 1. So for our question we have sine 3 over x will be between -1 and 1, and then you have to multiply all sides by x to the fourth, and since x to the fourth is a positive quantity, then no need to change the signs of inequality, so multiply all terms by x to the fourth, and you will get that x to the fourth sine 3 over x is between x to the fourth and negative x to the fourth. Now the function we have in the question is between the function negative x to the fourth, and let's say this is f of x, and the function x to the fourth is g of x. Now you have to replace x equals 0 in both functions, so we have f of 0 equals -0 to the fourth, and this is equal to 0, and here we have g of 0 equals 0 to the fourth, which is equal to 0. Now since the boundaries f of x and g of x goes to 0, as x goes to 0, this implies that limit x to the fourth sine 3 over x when x goes to 0 equal to 0 by squeezing theorem. For the second question, part B, we have the function f of x is between 6 minus x squared and 6 cosine x. So let's say that 6 minus x squared is g of x, and 6 cosine x is h of x, and you have to find limit f of x when x goes to 0. So firstly, using the squeeze theorem, you have to replace or plug in 0 in the two functions. So g of 0 equals 6 minus 0 squared, and this will give us 6, and by replacing 0 in the second function h, we have h of 0 equals 6 cosine 0, and cosine 0 equals to 1 multiplied by 6 equal to 6. So g of x goes to 6 as x goes to 0, and h of x goes to 6 as x goes to 0. So by squeezing theorem, limit f of x when x goes to 0 equal to 6 by squeezing theorem. Now in part C, with the same method we did in part B, the function g of x is between cosine pi over 2x and e to the x minus 4. So let's say that cosine pi over 2x is f of x, and e to the x minus 4 is h of x, and you have to find limit g of x when x goes to 4. So you have to replace 4 in both functions. F of 4 equals cosine pi over 2 multiplied by 4, and this will give us cosine 2 pi, and cosine 2 pi equals cosine 0, which is 1. And secondly, you have to replace in the function h of x, so h of 4 equals e to the fourth minus 4, which give us e to the 0, and e to the 0 is 1. So f of x goes to 1 as x goes to 4, and h of x goes to 1 as x goes to 4. So by squeezing theorem, this implies that limit g of x when x goes to 4 equals to 1 using squeezing theorem. So this is the idea of the squeezing theorem, and that's it. Thank you.